11 million human beings depend on this river, and so do innumerable creatures and plants. So, in times when conservation is an increasing concern, it's not surprising that it's also a major responsibility for the people whose job it is to maintain the balance of this massive ecosystem, Thames Water. In this program, we shall be looking at some of the environmental issues typically facing them. We begin in the Chiltern Hills, where a tributary, the Misbourne, is disappearing.
Oh, that's just as it used to be. Yeah, the waterfall there. This is the Abbey, and this is the waterfall where it ran under there. You can see the depth of the water there because there's the bridge. This is the bridge that was that side, and that's nearly up to the top there. In the middle of here, it's 3 foot deep at least. Oh, we had a lot of fun there.
Over the past 40 years, Percy Richardson has seen the trout river he knew in his childhood dry up and disappear in its upper reaches around Great Missenden, because too much water is being pumped from boreholes in the chalk hills that should be feeding it. John Lawson, a water engineer, is studying the problem.
Well, we were appointed by Thames Water in November last year to undertake a year's study of 6 rivers in the Thames Water Authority area, of which the River Misbourne is one, to investigate why chalk streams have dried up, the extent to which flows have been reduced, what the effect on the environment has been of the reduction in flows, to think about to what extent flows could be improved and how they could be improved. When the level of water in the valley drops below the bed of the river, then the water can no longer flow into the river and it dries up.
The study has established from historical records that before water abstraction began in earnest here around 1940, the Upper Misbourne was a substantial river. Vic Watton has written a book on its history.
One of the earliest documents that I've got relates to a meeting held in this part of the valley about 1940, attended by all sorts of people, all saying the same thing: why has our river gone?
For most of the time, it would have been a river about 5 to 10 metres wide. It would have been crystal clear. It would have been full of the vegetation that we expect to see growing in a chalk stream, as we know them in southern England. There would have been trout. It would have been very beautiful. In other parts of the country, the amount of water which is being abstracted for water supply represents a very small proportion of the total rainfall which is sinking into the ground, whereas in this river, something like 2/3 of the rainfall which is infiltrating into the ground is taken out again for water supply. Fundamentally, you have to get water back into the river, and there are 2 ways of doing that. Either you can get the springs to flow again, or you can artificially put water into that channel.
We've had tremendous cooperation from the local conservation and local interest groups. We want to discuss fully with them the implications of the options that have been put forward by Halcrow, and it's then our intention to proceed in a steady way to actually implement some of these options. Of course, any scheme for improving the river flow in these rivers will cost money. In our 5-year capital programme, we have put aside £8.5 million. Water resource management is one of our fundamental duties. Water is a valuable product, and we have a duty to manage it sensibly, and we have to balance the competing uses. In this particular case, my view is that water supply has taken too much out, and we have to actually put more water into these rivers to actually improve the uses of the water which are dependent on flow in the river, the flora and fauna and the amenity consideration.
A river is a part of the natural creation. It's as much part of the world as we are, as any living thing is. A river is a living thing. It will not look after itself, unfortunately. It has to be looked after. And the case for getting it right is to restore a feature of the landscape so that ordinary people, walking on their own feet, can enjoy the open air, watch fish, birds, splash in ponds, and enjoy life, especially in their early childhood.
rivers need to be looked after. And that involves engineering by the Water Authority. But unless it's planned and done sensitively, work like this can easily upset the delicate balance of a river's ecosystem. Or, worse still, destroy unique habitats that are vital to the survival of particular plants and animals. Thames water engineers now consult with conservationists at regular meetings where programs of work are reviewed and often modified in the light of their possible effect on nature.
They seem to be of high natural history importance, and so we'd like a very sensitive approach in those sections.
If we did, then obviously we'd consult, but it's just a ditch there, and when we saw it, it wasn't carrying any water anyway.
Yeah.
Nigel Ajax Lewis is Trust Officer of the Berkshire, Buckinghamshire and Oxfordshire County Naturalists Trust.
We liaise on a number of levels through various meetings and consultations. And it's here that we've been able to make a major input as a naturalist trust in providing ecological information on the rivers they're proposing to do something with because they have an operational problem. We can produce information for them so that they can undertake their works in the most sympathetic manner, rather than in the old days, water authorities in the 60s and 70s had rather a bad reputation for treating all rivers as drainage ditches and trying to straighten them up and get the water to the sea as fast as possible. This is no longer the case by any manner of means, and Thames, probably out of all the water authorities, has in fact made considerable efforts in taking account of all the factors involved and being prepared to listen to the likes of us.
All of this area is one of the county's most important areas for kingfisher.
As Thames Water's Conservation Officer, it's Alastair Driver's job to strike a practical balance between engineering and conservation.
In consultation with the Nature Conservancy Council, we've agreed to create a sedge-dominated shelf behind the piling, and we're doing this by putting in gabion baskets, these wire mesh baskets laying behind the piling, which have the bottom half filled in with gravel rejects, and then the top half infilled with sedge-dominated material, in which birds like great crested grebes, etc., could nest in later on in the summer.
Reservoirs like these at Walthamstow have become increasingly attractive to wildlife, especially in London, and a number of them are sites of special scientific interest, legally protected by the Nature Conservancy Council. This gives Thames Water additional responsibilities towards nature conservation.
Because the Nature Conservancy Council has recently re-notified this as an SSSI, we have been keen to establish a formal management agreement for the site. And that means sitting around the table with the NCC and our engineers and fisheries staff to decide exactly what operations we can carry out without consulting the NCC, and what operations may be damaging to the site and for which we should discuss the procedure further. Well, we get all sorts of unusual winter visitors here to the site, particularly in the wildfowl line. Ducks like goldeneye and sawbills like goosander and smew. And we also get more terrestrial oddities from time to time, which are on passage migration, like the long-eared owls that we saw today. There's also a very large heronry here, which is scattered over a couple of the islands. And this heronry is of such a size that makes it amongst the top 5 in the country. And then there are other little oddities on the site, like a resident cormorant population throughout the year, although they don't actually breed here. There are fairly large numbers here in the summer, up to 100.
The Walthamstow cormorants have given rise to some interesting tensions between the birdwatchers and the anglers.
We stock these reservoirs with trout for people to come and take, and obviously the cormorants take a lot of the fish that are swimming around freely in the reservoirs. One cormorant would take on average 1 fish per day, which should be say a 12-inch fish, and it may severely scar 2 or 3 other fish before catching that one. So we're building up to perhaps several thousand fish lost every year through cormorant damage.
child, I thought fairies danced because my father was so interested in it. I thought there must be something of that sort. But I've never discovered why it's called Dancer's End. It really, Dancer's End was part of the original Tring Park estate, which was bought by my great-grandfather. But Dancer's End itself appealed particularly to my father because he loved the wonderful flora and fauna that you found at Dancer's End, and also it was a spectacularly beautiful area, really. And he was very anxious to make it into a nature reserve.
Thames Water first became involved in this site from a conservation viewpoint about 2 years ago now, when the local naturalist trust, Beebont, wrote to me with a report of the wildlife interest of the site. Following that report, we met up on site, and I was absolutely amazed to find that a site of this value, both from a species viewpoint, individual species viewpoint, and from a habitat aspect, could remain unprotected in this day and age.
That's a first for this site, not recorded before. It's a plant related to the ferns, and instead of throwing seed, it throws spores out of this central column.
County Naturalist Trusts and groups like the Nature Conservancy Council and the RSPB have an enormous amount to offer water authorities. First of all, they can provide local information on sites that we own, and we own in the region of 8,000 separate properties, and many of those are rural sites, so there's no way that we could get to know the conservation interest of all those sites without their help. Secondly, they can provide expertise in the form of survey work.
When we started looking carefully at this site, we discovered well over 100 species of flowering plants quite rapidly, and that's for a very small area, and we think there are a lot more to discover yet. For instance, on this site, I think 9 different species of orchid, a whole series of plants like bird's foot trefoil and kidney vetch, which are food plants for quite scarce butterflies. The sort of undisturbed grassland that we find on this site is terribly important these days. Most of the old bits of chalk grassland around the Chilterns have been lost to agricultural use.
Well, on a nice fine afternoon, you know, you can see all sorts of wonderful things at Dancer's End. Cowslips, of course, very characteristic of chalk, and they're extremely, extremely valuable flower for all sorts of insects, really. The Duke of Burgundy fritillary feeds it also occasionally feeds on the primrose, but it's a cowslip feeder. And it's very good. It's a very, very nice plant to have up there. You know, it's become a special science now, the interrelationship between plants and insects, these herbivores, and it's an extremely interesting ecological spot, Dancer's End. Plenty of orchids there, fly orchid, and the butterfly orchid. And then, of course, as they're beech woods, you also get the bird's nest orchid there.
A great many of the wild and beautiful places Thames Water owns aren't in the wilds at all. They're in London. The Middlesex filter beds are in Hackney, 4 miles from the city.
This place was abandoned in the late 60s. What happened was that the sand was taken away from the different beds at different times. So the places where the sand was taken away the earliest, perhaps, have the oldest vegetation. Then when the sand was taken away from the other ones, they began to catch up. But the fact that there's a different history, if you like, in the last few decades for each of the beds means that some of them have open water, some of them reed beds, wildflowers, others trees and bushes. And that means that you've got a great variety of habitat. So you've got everything from open water with wintering ducks visiting, to bare mud where little ringed plover might breed, to trees where your spring warblers will be singing round this site, not at the moment, but in a couple of weeks or so. And underneath all that vegetation and amongst all those birds, you've got very good dragonflies, a tremendous population of common newts, and butterflies, moths and insects in general. So it's all round a place of tremendous variety, stuck in the middle of the East End of London. The trees are unusual, in particular the poplars and willows.
Well, this is a unique colony of poplar trees which germinated spontaneously about 12 years ago when this would have been an open mud area. And what's especially interesting about it is that all the trees are of hybrid origin because the neighbouring trees which were planted on the playing fields nearby actually cross-pollinated. It's unique in the world. There is no other colony known to science that is anything like this at all.
Other varieties of poplar here are numerous, and there are lots of different types of willow here. So that makes it a botanical mecca in the tree sense.
Besides their conservation value, places like this also have potential for property development. How does Thames Water reconcile these different values?
We own in total something in the region of 21 square miles. That includes, of course, rather a lot of water as well as land in itself. We have a total area of redundant land of about 100 to 150 acres. But more importantly, over the next 5 to 10 years, even more land will become redundant as we introduce new technology to deal with water treatment. When we're dealing with redundant land of great conservation interest, we have a special policy which makes sure that everybody and all the interested bodies in the conservation field have an opportunity to express a willingness to buy that land, and in effect that gives them a kind of first refusal. Sometimes they can't afford it because funds are always very tight, but otherwise we will try to reconcile conservation interest along with our commercial interest. Difficult balance to strike, but we try.
Thames Water will be handing the site over to the Lee Valley Park Authority, hopefully this year. In fact, the Lee Valley Park is negotiating a lease with Thames Water, a 999-year lease with Thames Water, to take over the site and develop it as a nature reserve and as an area for public recreation and walking, bird watching, and those sort of activities. In the late 60s and early 70s, the attitude was, in fact, that this site could have been sold off for development. There was a terrific local interest in the site as an open green space, and I think Thames Water being far-sighted in allowing this to be developed as a nature reserve area.
One of the problems we have in the nature conservation movement in urban areas is with high land values, trying to justify our case against the property developers, if you like. But organisations such as Thames Water Authority do in fact have a duty under the Wildlife and Countryside Act to further nature conservation. On the wider spectrum, we would say to property developers, what we're trying to do is just make the city a bit more livable in. It's okay to put tarmac and concrete everywhere, but actually people want a quality of life. It's not just a standard of living, it's a quality of life.
About a mile away, another much bigger Thames Water property, the Stoke Newington Reservoirs, is about to become redundant too. The local community is anxious to see it conserved as open water, along with the new river that feeds it.
There's enormous concern locally about the future of the reservoirs. We've had hundreds and hundreds of responses, both to our consultation, to people attending meetings. There have been constant letters in the local paper on the subject. People are obviously really, really concerned about the future of the reservoirs. It's an area of very high population density. There's something like 5,000 people who are living in homes immediately surrounding the reservoirs and filter beds. There's about 26,000 people within easy walking distance and over 250,000 within a short bus ride. The two reservoirs, filter beds, the new river, all together form a wonderful open space in Hackney.
Our disposal policy is governed first of all by government, which says that we must get the best price. Somebody's got to find money, and we feel that would most probably best be achieved by marrying the local authorities' objectives with some form of commercial development in a sensitive manner. And at the end of the day, this site is not going to be needed by Thames for its business purposes of treating water. New uses have to be found, they have to be viable, they have to be capable of being implemented. And that's why we feel we have a duty to strike the balance.
There have been mills on the site at Cobham since at least the Doomsday Book. This is the last in line after a number of rebuildings. This mill here is the last surviving one. And Thames Water recently took the somewhat unusual step of actually acquiring it. As a listed building, we have to make sure that it stays up. And we will be making sure that that is a sound structure for all time. From that point on, the local conservation society have formed themselves into a preservation trust.
Well, I think the interest of the TWA is both pragmatic and socially very interesting because, first of all, their prime interest is to see that the mill doesn't fall into their water. We were delighted to find that they have an archaeological department with people with the time and the interest to look at our special needs, and we have no problems whatever on that score.
On the main river itself, at Gatehampton, near Goring, Thames Water engineers are putting in new boreholes and pipelines for drinking water. But the site is also known to be a Bronze Age burial ground. So the Oxford Archaeological Unit has first been brought in by Mike Hall to excavate the site before engineering work begins.
When engineers are planning a major new work like this one, they will send me their plans at the earliest stage of their thinking. And I and my other environmental colleagues can examine those plans against all the known databases. And we can go back to the engineers and say what we like about the schemes or warn them if there are things which are environmentally unacceptable.
In charge of the dig for the Oxford Archaeological Unit is Tim Allen.
We'd seen from aerial crop marks, aerial photographs of crop marks, that there was a series of circles, that is Bronze Age ditches round barrows in this field, running along the edge of the gravel terrace, just where it dips off onto the floodplain down to the Thames. So we knew that there was a cemetery of about 2000 BC here. We didn't expect, in fact, when we started digging our trench ahead of the Thames Water pipeline, that we'd find a great deal. Perhaps the odd cremation around the edge of the barrow, perhaps a secondary burial or two added by people respecting the barrows, but little else. Well, in fact, we were pleasantly surprised because we found a good deal more than we expected.
The public have demonstrated in many ways that they are interested in all aspects of the environment. So when we do this work, it is just part of our normal environmental duty and something which really these days we are expected to do. A river is a provider. A river is all things to all people in what it can do for them. Geographically, it can be a boundary, or paradoxically, it can be a highway that people can go up and down either on boats or just using it as a track along which to run. It can provide all the staples of life, not only water, but fish and fowl to eat, reeds for building, thatching, even clay for pottery. And it also provides wide tracts of very fertile soil to grow crops on. So a river is a good place to be.
The last major floods in the Thames Valley were in 1947. Since then, development around London has increased the risk of flooding because instead of soaking slowly through the ground, rainwater runs straight off concrete and tarmac into the streams and rivers, swelling them quickly. Places like the Colne Valley are at particular risk.
In 1947, the floodwaters extended from side to side of this valley. That's from just short of those houses to right across the valley, across the lakes here to the other side, which is perhaps a kilometre away. And all you'd see here was a lake with the alders sticking out of it. Well, Thames Water was so concerned about the degree of development that had gone on since 1947 in the Colne Valley that the building of the M25 motorway was the last straw. So we had to establish what indeed was the present-day risk of flooding. And to do this, we built possibly the world's most sophisticated river model of this very complex system between Rickmansworth and Staines. At the end of it, we were able to predict flood levels, and from those levels, we were able to establish what would be the level of damage that would be caused to property within the valley. We then put in train a number of environmental studies which we hoped would encompass those areas where we felt we were bound to carry out some works.
On a scheme like the River Colne, there are a whole range of interests that one would want to consult with, like the NCC, the Royal Society for the Protection of Birds. Those people we know are very skilled in the areas that we're talking about, and you can go to them very early on in the study to get feedback from them. And in fact, we went in with those groups before the engineers even started work, just to put that into perspective.
Amongst the conservationists consulted was Tony Hare.
This is a fantastically complicated and fascinating area, really. It's got the river running north-south, you've got the Grand Union Canal coming in and crossing with aqueducts, you've got huge areas of island covered in nettles and trees, you've got the banks with all their vegetation, plants and birds. We can hear 2 or 3 species of birds singing around us now, just as we sit here. Common birds, yes, but even so, you can hunt around and find less common things. There's also a habitat that I'm particularly interested in, and that's the flood meadows, if you like, by the side of the river, flooded in winter, dry in summer, usually grazed, and full of a variety of plants which are the plants of ancient grassland. At this time of year, they're spangled with the red of ragged robin and the pinky white of lady's smock, and then meadowsweet, and some rather uncommon things as well, perhaps some orchids, or perhaps things that are a bit of a connoisseur's plant, like marsh arrowgrass. Really boring plant to look at, green, nothing happening at all, but an exciting thing to find because it is uncommon and it's very typical of old, unspoilt, unimproved meadow.
You set up a framework where the engineers and the various environmental groups are able to interact frequently, looking at the possible solutions for flood alleviation, so that you gradually refine your options until you end up with a preferred scheme which is made up of a series of proposals which, as far as you can reach a consensus on, have the minimum environmental damage to solve the flooding problem that we're looking at.
In the past, engineers, river engineers, have had their job to do, as indeed they do now, and they've solved it in a way which hasn't always been particularly good for nature conservation. No, that's not their fault. They probably care about nature conservation as well, but there's no reason why a river engineer should have a particular expertise on what's good for natural history. But to their credit, Thames Water, in this particular instance, have involved ourselves and other people in a consultation process, which has meant that we can talk with the engineers and talk with everybody who has concern over this scheme in order to present our views, and other people can present their views, be it angling or be it bird watching or be it whatever you like. And the end result of that, of course, is that you haven't got an unsympathetic scheme to nature conservation. You've got a scheme which, all things considered, is very, very good indeed for nature conservation, and yet is also doing the job that the engineers have to do with the flood alleviation side of things.
On On April the 2nd, 1985, a lorry crashed on the M11. It tumbled down the bank, spilling 500 litres of its load of chlorpyrifos insecticide into the River Roding. Over the next 48 hours, this intensely toxic chemical travelled down the river, killing virtually the entire population of fish, as well as millions of the tiny invertebrate animals they feed on. A freshwater biologist, Paul Raven, has been studying the gradual recovery of the river.
The pollution travelled 30 kilometres down into the Thames estuary where the Roding joins the Thames estuary, and there was even implications that animal life was in fact killed in the Thames estuary itself during the first 48 hours. The toxic amount of this chemical that went in would have had a very dramatic effect even on a river as large as the Thames. And it would require roughly 1 teaspoonful in a swimming pool to kill 50% of the freshwater shrimps. Thames Water reacted very quickly to the accident. We're on scene within a matter of half an hour or so, but could not do anything like damming the river and pumping the chemical out until they knew exactly what the chemical was and what its properties were. The length of time was about 2 hours from the time of accident to the time at which the chemical company actually cleared the identification of the chemical, by which time it was too late to do anything other than let the poisonous slug of the chemical flow down the river.
We have a large number of pollution incidents, several thousand a year. A large number of these are small quantities of oil, toxic waste from industry, and occasionally, I have to say it, problems with our own sewage treatment works. Generally, these incidents can be looked after quite quickly, and occasionally they can be severe. We have staff on permanent standby, able and willing to get to work on these incidents as they occur.
One of the big concerns is the labelling. We still don't have a standardized EEC labelling system for a lot of hazardous materials. And it can often take a very long time for water authorities to find out what is actually coming into their water in any major accident.
Pollution from agriculture is a growing problem throughout the whole of the country. Fortunately, in Thames, we're not so affected as some of the other water authorities. The difficulty is that, unlike industrial discharges, many of the problems arising in agriculture are so-called diffuse or non-point sources, and pesticides are a good example of this. Some of the advanced pesticides and fungicides in very small quantities can be highly toxic.
Pesticides have become an increasingly serious problem with regards to water pollution and river quality. And one of the major difficulties is that we cannot actually estimate the damage because it's very difficult for water authorities to test for certain kinds of pesticides. And we are increasingly concerned that although they say they're doing sufficient monitoring and they know when there's been a particularly serious pesticide pollution episode, what they can't test for is the kind of backdrop increase in a large number of different pesticides, combining together in ways that we simply don't understand as yet. And the impact of that, cumulatively, is, we think, much greater than at the moment the water authorities are letting on about.
As always, we are trying to balance costs against the need to improve matters. Sampling and monitoring is a very expensive process, and we can't easily afford to be at all spots at great frequency.
I think it just simply isn't the case at the moment. The water authorities are putting enough resources into the monitoring. It's very difficult for them to do so because with some of the pesticides that we're talking about, there are no known procedures for actually assessing them, and the levels are often so low that they simply don't know how to find them. So it is an expensive business, and we're not saying this is a cheap thing, but if we demand the use of those pesticides in our society, then it seems only reasonable that the regulatory authorities concerned should be able to detect the presence of those pesticides and should be able to say when there's too much of it. I actually think it would be unfair to lay the whole burden on the water authorities. They are not the ones who are getting the benefit from the use of these chemicals. It's the farmers, and even more than the farmers, the chemical companies. To me, therefore, the prime financial burden should actually be brought to bear on the chemical companies themselves.
With as many as 1,000 new chemicals reaching the market each year, Thames water chemists like Richard Vincent face an increasing challenge.
I think in widespread commercial use there are something approaching 4 million different chemicals. Fortunately, we don't yet have to analyse for all of those, but it does of course mean that as time goes on, that we have to deal with ever more and more chemical determinations in a way perhaps which we didn't have to deal with 20 or even 10 years ago.
Thames has responsibility for over 3,000 miles of significant rivers and streams. Those are the ones which we regularly sample and report on. There are, of course, many, many more miles of much smaller, but environmentally important waters which people treasure.
But to get a true picture of the state of health of a river, Thames water needs more than chemists. It needs freshwater biologists, like Tony Dearsley.
If you think, first of all, what's involved when chemical samples are taken from a river, the sampler will come along and take a sample from a particular location in a river, and we're able to do that perhaps 12 to 20, 24 times a year at the sampling points on our rivers. Now obviously if you're only taking a discrete sample like this maybe 20 times a year, then you could miss an awful lot that's going on in the river, because as you can see it's flowing 24 hours a day. The other point is that when that sample's taken, the discrete sample, and it goes back to the laboratory for analysis, then the chemists generally analyse for perhaps 8, 10, 15 of the commoner indicators of pollution. Now, as we know, there are certainly several thousand chemicals which could get into the river, and maybe we should be thinking in terms of millions these days. So you can see that there are two shortfalls, if you like, or shortcomings of the chemical monitoring programme. Now, chemistry could overcome that if we had continuous monitoring stations every 10 kilometres over the thousands of rivers that we had, and they were set up with equipment to monitor every known chemical, then yes, you will overcome the problem. But of course that's prohibitively expensive. So this is where biology comes in to plug that gap in our knowledge which is inherent in this type of sampling approach.
The riverbed is home for an astonishing number and variety of tiny creatures. And in a healthy river, a biologist knows exactly what should be there.
We're talking here about shrimps, we're talking about mussels, snails, the larvae of a whole range of insects, worms, this type of thing. And we also know that each of the different types of organism has a different tolerance to pollution. These animals living on the bed of the river are there 24 hours a day, 7 days a week, 52 weeks a year. And that means that when you take a sample and examine it and assess water quality, you're not just assessing water quality now at this particular moment, but the water that's flowed over here for several weeks or even months in the past.
But many environmentalists argue that Thames Water's monitoring of the rivers cannot keep up with increasing pollution problems from agriculture, industry and sewage.
The problem now has become obviously apparent that in fact our rivers are not nearly as clean as one would expect them to be. And the problem there is that we do not in fact have the sewage installations that we ought to have for the increasing size of the settlements that we have, particularly in this part of the world. The two that come to mind immediately are Aylesbury and Banbury, where the rivers Tame and Cherwell are in fact being majorly polluted.
It doesn't seem to us unreasonable for government actually to make some grants available to the water authorities for specific new construction projects to improve the situation. And I think that would be one thing that one could look at very sympathetically. But it must be said that if that's what it costs to deal with the sewage from the human population, then that's what we must pay. We are the producers of this effluent, and we are the ones who should be paying for it.
Sewage treatment is a vital stage in the water cycle, and its success depends on multitudes of tiny organisms like this. These are the unsung heroes of our ecosystem. Flocks of microscopic creatures that graze on sewage, breaking it down to create effluent that should be pure enough to recycle into our rivers. They can deal with organic matter, but they cannot tackle the chemical wastes in the sewage.
Thames Water Authority, along with all the other 9 authorities in Great Britain, spend between 20 and 30 million pounds every year monitoring 16 different chemical compounds. Within the European Commission, at present, over 10,000 different chemicals are produced in quantities in excess of 1 tonne. If Thames Water Authority and the other water authorities were asked to improve their monitoring capability to cope with that number of chemicals, they would have to increase expenditure from 20 to 30 million pounds to 11 billion pounds. That's equivalent to the cost of Trident. We argue that they're simply not in a position to do that, and as a consequence, we would like industry to begin to treat its waste at source and not to leave the problem of its waste in the hands of Thames Water Authority, who have to use funds raised from the public sector to try and monitor the environment as best they can. The Water Research Centre argue that the technology exists to treat waste to whatever standard society demands. The great problem in Britain at present is that society's demands, as reflected in government policies, don't demand a great deal.
Every day, Thames Water ships out processed sludge from the giant sewage works serving London at Beckton and Crossness to the North Sea for disposal.
We take 2,290 tonnes of sludge on each trip. We take it out to the Barrow Deep, which is right at the end of the Thames estuary. It's just inside the PLA limits. We end up about 25 miles off Clacton.
Thames Water Authority are responsible for not only treating and getting away the many millions of gallons of sewage from London, but also they're responsible for maintaining fisheries and improving fisheries and protecting the flora and fauna in the river. So that is quite a balancing act. You have the managers on one hand who want to save as much energy and give the minimum of treatment to their sewage compatible with having a good river, and on the other hand you have the environmentalists who are saying get the river as clean as we possibly can, have all the animals back. So a lot of information has to be gathered to get that balancing act in proper perspective.
The reason it goes into the sea is that authorities like Thames have actively encouraged industry to pour their effluent into the sewage system, which means that the sewage sludge, which could be used as a fertiliser if it didn't have the industrial waste component, is unable to be used in that way. Greenpeace considers, first of all, the fact that Britain is the only country dumping sewage sludge into the North Sea as a tremendous problem, and secondly, the fact that the amounts of sewage sludge dropped and the amount of industrial waste involved in that component is placing the southern part of the North Sea under a tremendous amount of environmental stress. We're already seeing in certain regions that 40% of all the bottom-dwelling fish are now diseased and have some form of growth.
At West Thurrock Power Station, Paul Johnson, a Greenpeace scientist, is investigating fish disease among flounder living in the estuary.
We're finding large numbers of animals with lesions of this sort and marks on the underside. We're also, in some cases, finding very, very large lesions on the opercular covers of these fish. Fin rot, where the fins have completely rotted away. Now, we don't know what the reason for this is in the River Thames. Certainly on the continent, scientists are beginning to research a link between pollution levels and fish diseases, and there certainly does seem to be some sort of correlation, but the reason for the diseases that we're finding in these fish on the Thames remains as yet unknown. And what we really need to do is conduct a very extensive research programme to find out exactly what's going on, to find out what pollutants are in the sediment, what pollutants are in the animals, and whether there's any relationship between them.
Thames Water are also concerned to find out more about the ecology of the estuary and the North Sea.
At present, we're running a very large project looking at the environmental effects of sludge dumping at sea. We're working in collaboration with the Water Research Centre, and it's a 4-year project. We're putting well over £1 million of money into that project, and we're looking at all aspects of pollution. We're trying to find any possible effects out there. If there's a problem, we want to know about it. So we're looking at the fish, we're looking at the invertebrates, we're looking at the dispersion of the sludge particles, the sediments, the chemistry of the sediments, and the water body generally.
What we're also very, very concerned about is the fact that sewage sludge contains a very high concentration of phosphate and nitrate. In the southern part of the North Sea, in the last 30 years, there's been a 7-fold increase in the concentration of phosphate and nitrate. What this has caused to happen is that there has been a major change, a switch in the composition, the species composition of the phytoplankton. The phytoplankton form the very base of the food chain in the North Sea. What this has led to is to the creation of 2 very large areas, roughly the size of Wales in the southern part of the North Sea, which are prone to catastrophic deoxygenation, areas which we call black holes, areas which are threatened to increase in size unless sewage sludge disposal, unless land runoff is stemmed. And what we argue is that sewage sludge disposal is an option which other European nations don't use, and is an option for which other non-ocean alternatives clearly exist.
Well, as always, we have to find a way through of compromise between conflicting objectives. The essence of BPEO, the best practicable environmental option, is to seek a balance between effectiveness of getting the job done, efficiency in terms of value for money, looking after the consumer's interests and the depth of his pocket, and safeguarding the environment.
The technology exists to treat any effluent to any desired standard. It becomes a simple matter of economics. And I think what one has to remember is that the number of shareholders in the environment greatly exceed the number of shareholders in the companies who are responsible for discharging these effluents, and whose primary loyalty appears to be to their own shareholders to whom they pay a dividend.
As shareholders in the environment, we all have a right to pure drinking water, and it's Thames Water's first duty to supply it. But a pike, or a damselfly, or a kingfisher also has a right to thrive on rivers that are well respected and unpolluted. How do you achieve the greatest happiness for the greatest number of people, species, and interests? For the world's largest water authority, the stewards of our most precious natural resource, it's a question of balance.